Good day. I'm going to be working a combination circuit problem. As you can see in the video here, we have a voltage on the battery or power supply of 24 volts. We want to calculate the total current, and we have three resistors. Two of the resistors in parallel in series with a resistor 1. General idea of working a combination circuit problem is to try to work it from the inside out, and anytime that you can do the parallel first, do it before you do the series. So let me go ahead and demonstrate. We're going to try and combine these two resistors. We always have to write down our formula. My nomenclature is to label it R2, 3, so you know which two resistors I'm working with, and I use the formula 1 over R2 plus 1 over R3. Plug in the values, so we have 910 ohms plus 1 over 760 ohms, and that works out to be 4. Would help if I moved it up, 14 ohms. Okay, so let me recap. This is the parallel formula I use. Plug in the unknowns, put this all in the calculator at one time. Let me remind you that you need to practice with your calculator. So I do 1 divide parenthesis 1 divide 910 close parentheses plus parentheses 1 divide 760 close parentheses equals, and I get 414, and I'm only going to be using 3 digits in my answers. So now I've got that. Now let's redraw the circuit. Okay. So I combine the two resistors here, and now we have a purely series circuit. And remembering the formula there, it is R total now is R1 plus R2, 3. Filling in the numbers, substituting 820 ohms plus 414 ohms gives us 1230 ohms. And you'll notice here that I am just giving 3 digits, but I have to put in a 0 here. I rounded, and there was 4 or less there, so I rounded it to 0. So, but the 3 digits are here, but that's a placekeeper. All right, now I'm not going to redraw it again, showing that I combined these two. We just know that now we have one resistor and a power supply, and remembering we are trying to find the total current here. Okay. So the formula we use is V equals IR. I like to make it a practice of going ahead and solving the formula for our unknown. We're looking for I, so divide both sides by R and transposing the terms there. So we get V divided by R, plug in our numbers, 24 volts divided by 1230 ohms, and we end up with 0.0195 amps. Remembering I'm using 3 numbers here, the 3 that matter, the 195, the 0 is a placekeeper. So you may at some time need to go ahead and change it into milliamps. So moving it 1, 2, 3 places to the right, that's 19.5 milliamps. Okay. Now, I want to remind you, when we're solving a circuit that has both parallel and series pieces, work from the inside out, and anytime that you can do the parallel first. There's no one, step-by-step solution. You just have to analyze the circuit and try to simplify it to find your, in this case, your total resistance, because that's what I need to define the total current. Now, sometimes you may have software that can help you see if you did it right. On my iPad, I have iCircuit, and I went ahead and drew a circuit with 24 volts. They left off the units. If there was kilo ohms, they would have put a K there, but these are understood to be in ohms. So I drew this circuit. I put in a meter on this wire here, and you can see that I'm getting 19.45, or if I round it off, 19.5 amps. It also shows you the voltage here. We started with 24 volts, and if we went ahead and looked at that wire there, what kind of voltage would we expect? Well, yes, 0, because remembering that is ground, and we have 0 voltage at ground. If we looked at this wire here, we could, well, actually, that shows you the element. If we looked at that, wire there, we can see our milliamps. And now, why is it not the same as the other? Because some of the milliamps, or some of the amps, split here, and some went here and here. If we looked at this side here and then added those amps together, it would get our original 19.5 milliamps. And that is an example of how to do a combination circuit. Thank you.